And what it's doing is it's asking for tool number 1. So I'm going to reach up here, I'm going to unmount my probe tool. And if you'll bear with me here while I do this. So tool number 1 is the 3/16 2-flute end mill. Tighten up the drawbar. Okay, so I have physically mounted tool number 1, and I'm going to tell that it's physically mounted, and it will come down and measure the tool length offset for tool number 1. Having completed the tool length measurement, it will now continue back to the run page and continue running the G-code program. Now, the program is paused here. You'll note if you look at the G-code here that what I've done is I've come back to be at the XY00 point, and then I've told it to apply the tool length offset for the tool that's mounted, and then the G-code sends it to 1 inch above the part. And if you look at this, I do this as a sanity check when hand coding, and indeed that is just about 1 inch, so we're pretty confident that we've got things set up correctly here. I'm going to go ahead and tell the program to continue. The next thing it's going to do is it's going to run down, turn the spindle on, and stop at 0.1 above the part. Now, the spindle has been disabled because I had the probe tool in there, and so it says, do I want to enable the spindle and continue? And I want to say yes. Now, this may be a little hard for you to hear me, given the amount of noise that the system makes, so I'm just going to go ahead and continue, and we're going to see it use the first tool. Now, I would normally run this with coolant on, but you won't be able to see anything if I turn on the flood coolant. So I'm just going to use the air hose here to try and keep the chips out of the way so that you can see what's going on as the program runs. So we're using T number 1, and it's cutting the outside circle of the happy face. And after it gets done cutting the outside circle, it'll come back and do the little decorative edge that is shown in the program just to give a border to the face. Okay, we finished the circle, now we're cutting the border. I'm not going to give a lot of narration at this point because it's unclear to me as I do this whether you can actually hear me through the microphone or whether the only thing you're going to get is the noise of the spindle running. So I'll wait until we get to another pause point here. Alright, we're raising to be up above the part. We've moved back to the 0 position. And what's happened is the program has hit its second tool change and it's now asking for tool number 2 to be mounted. So, I'll do a little recap here. I have no idea if you could have heard me over the machine noise. We'll see how the video comes out. But we've cut the initial outside edge for the decorative pattern and we've cut the circle that frames the happy face. I'm going to go ahead and change to tool number 2 now. Oh, that tool got in there tight. There we go. Okay, we've taken tool number 1 out physically. Going to put tool number 2 in. Okay, we have tool number 2 physically mounted. So having physically mounted tool number 2, I'm going to come in and say yes, the tool is mounted, and it's going to measure the second tool for tool length offset. The second tool is the 1/8 inch end mill that's used to cut the little eyes, nose, and mouth into the Happy Face sample program. So we're going back to the tool change position, and it will continue running the code. The code then takes me back to XY00, and again down to 1 inch above the part. It pauses here because of the optional M01 stop, and you'll notice we are 1 inch above the part, and that's a good way to confirm that, having measured a tool of a second length now, that we do indeed have the right tool length offset to finish cutting the features. So it's going to get noisy again as I start to spindle up. I'm going to let it cut through the end of the program, and then I'll have some more commentary at the end. Okay, so we finished cutting the part, and you can probably see we've got a little Happy Face cut out here of a 2x2 inch aluminum block. I'll go ahead and take it out of the vise so that you can get a little better look at it, and we'll see how that shows up in a program. But as you can see here, that's what the sample program was supposed to do, and we have our little sample part. Now, what I want to observe about this is that this was a fairly simple operation. I started up, I loaded the code, I mounted the probe tool, I used the probe tool to set the 0 point for the stock. That told the system where the stock was, and then using master tool mode, it automatically measures the rest of the tools relative to that first tool, and away we go. Every time a tool is mounted, it's measured, and the offsets come out right, and all you have to do is physically mount the tools. Now, it is required that you have set up, of course, the diameters for the tools in the tool table first, but you don't have to do any pre-measuring. You can do all the measuring of the tools online as the program runs. So that gives you an idea of how easy it can be to do this when you've got all the options right. Now, I want to make one note of caution here. In using master tool mode, the tool length offsets are always relative to the master tool. In this case, I use the probe tool as the master, and it doesn't really matter that we're using the probe tool as the reference length, except that you do need to recognize one thing. Master tool mode is often used in industry so that you can set up a set of tools, and what you do is you measure them all relative to the master, and then as long as you don't change the length of the master tool, you can use the master tool to set your zeros, and all of the other tools are already set up. So if you have repeatable height holders, you can actually set up your tools once, and you don't even have to bother with the measurement during the tool change process. However, the flip side of that is that if you do change the length of the master tool, all the other tool length offsets in master tool mode will now be incorrect. So anytime you change the length of the master tool, you must remeasure all of your tool length offsets. Now, I've avoided that situation here in this demo because what I did was I simulated using all non-repeatable height holders. And so the situation here is that anytime I mount the master gets measured. And anytime I mount any other tool, the tool is also measured. So this forces us into a situation where the tool measurements are always done after the master has been measured, and it doesn't matter if the master was in a repeatable height holder or not, because as long as it gets measured when it's mounted and all the tools get measured when they are mounted, you won't have the problem of having had the master change. So as long as you're using all non-repeatable height holders, just leave off the option on the tooling page which says skip RH tools, and you'll be fine. If you decide to use a mixture of repeatable height and non-repeatable height holders, then you need to stop and think about this and make sure that you aren't using them in the wrong order, because if they're relative to a master and you change the master, that will cause your offsets to be incorrect. So just one word of caution, but if you just do the simple directions that are here, you can see how easy it is to cut the part. So I think that's the end of what I want to demonstrate in this video. I hope that was helpful to you, and I look forward to seeing you in later videos in the series. Thank you.